China is drilling deeper into the earth than anyone ever has, chasing secrets buried for millions of years. But what will they find in the darkness? Hidden energy, ancient life, or something far more dangerous? As they push into the unknown, they risk triggering immense pressure and unleashing volatile forces that could have catastrophic consequences.
Why is China drilling so deep? In the heart of the Sichuan Basin, a region known more for its breathtaking landscapes and ancient history, something extraordinary is happening far beneath the surface. China's top engineers are undertaking an unprecedented project, drilling a hole that will plunge over 30,000 feet into the Earth's crust. To put this into perspective, that's deeper than the Mariana Trench, the deepest part of the world's oceans, and taller than the mighty Mount Everest if you were to place it upside down. As ambitious as this sounds, it's just the beginning. Up in northwest China's remote and arid Tarim Basin, another team is preparing to delve even deeper into the Earth's crust, aiming to reach an astonishing depth of 36,000 feet. This remarkable endeavor represents about 0.09% of the Earth's diameter. Should these projects succeed, they will rank among the deepest holes ever dug by humans. But this raises a compelling question. Why is China so determined to dig so deep? At the heart of this monumental effort is a dual mission that intertwines scientific curiosity with strategic objectives. On one hand, the pursuit is purely scientific. Imagine the Earth's crust as a giant, multi-layered history book, with each stratum representing a different chapter in the long and complex story of our planet's formation. The deeper you go, the older the pages, and the further back you travel in time. By drilling into these layers, scientists can unlock secrets buried millions, even billions, of years ago. This isn't just about scratching the surface, it's about delving into the very fabric of the Earth's history, uncovering data that could shed light on everything from ancient climate patterns to the origins of life itself. For scientists, this deep drilling is akin to a time machine, offering glimpses into Earth's primordial past. They hope to encounter rock formations, minerals, and even fossilized remains that have been untouched for aeons. Such discoveries could provide invaluable insights into the planet's geological evolution, helping to answer age-old questions about the forces that shaped our world. For instance, by analyzing these deep Earth samples, researchers could gain a better understanding of plate tectonics and the processes that drive earthquakes and volcanic activity. These insights could, in turn, lead to improved predictions and potentially save lives in regions prone to such natural disasters. Yet, China's drilling projects aren't solely about satisfying scientific curiosity. There's a more strategic angle to this endeavor, an angle that speaks to China's growing global ambitions. Motivations behind China's deep drilling. The project, launched in 2021 under the leadership of President Xi Jinping, aims to penetrate deep into the Earth's crust, reaching layers formed over 145 million years ago. It's an ambitious undertaking that could transform both scientific understanding and the nation's energy landscape. The Earth's crust is a time capsule, holding within it the story of our planet's evolution. Each layer represents a chapter in that story, with the oldest layers offering glimpses into a world long before humans existed. China's Deep Earth Exploration Project is like peeling back the layers of an ancient manuscript, revealing the secrets of Earth's distant past. These secrets are not just of academic interest, they could have practical applications that extend far beyond the realm of science. At the core of this mission is the potential for discovering vast energy reserves. Beneath the Earth's surface lie untapped resources that could fuel China's continued growth and development. As the nation seeks to secure its energy future, the potential for finding new reserves of oil, gas, and other valuable minerals is a tempting prospect. The deeper the drill goes, the greater the chances of uncovering these hidden treasures, which could provide a vital boost to China's economy. President Xi Jinping's Deep Earth Exploration Initiative is more than just a drilling project. It's a symbol of China's commitment to innovation and progress. By pushing the boundaries of what is possible, China is positioning itself as a leader in both scientific research and technological advancement. The project's ultimate goal is to reach materials formed during the Mesozoic era, a time when dinosaurs roamed the Earth, and the planet was a vastly different place. By studying these ancient materials, scientists hope to gain insights into the Earth's internal structure, the processes that have shaped it over millions of years, and the environmental factors that have influenced its evolution. The data gathered from these deep layers could revolutionize our understanding of geoscience. By analyzing the composition and properties of the Earth's crust at such great depths, scientists can develop new theories about the planet's formation and evolution. This knowledge could also have practical applications in assessing environmental risks. By studying the deep layers, scientists can gain a better understanding of the factors that contribute to natural disasters like earthquakes and volcanic eruptions. This information could be used to improve disaster prediction and mitigation efforts, potentially saving lives and minimizing damage. The Kola Superdeep Borehole. Among the most audacious attempts to penetrate this subterranean world is the Kola Superdeep Borehole, a monumental scientific endeavor that remains the deepest man-made hole on Earth. Despite being shrouded in mystery and often overshadowed by more glamorous feats, this borehole, located in Russia, represents one of the most significant achievements in geological science. The Kola Superdeep Borehole project began in May 1970 during the height of the Cold War. It was initiated by Soviet scientists in a bid to outpace the West, not just in space exploration, but in unlocking the mysteries hidden deep within our planet. The site chosen for this ambitious endeavor was in the Pechensky district of the Murmansk region, near the Norwegian border. The goal was simple yet profound: to drill as deep into the Earth's crust as possible and uncover the secrets that lay beneath. What started as a scientific project quickly became a symbol of Soviet prowess. The task was monumental. Drilling into the Earth's crust required overcoming immense technical challenges, including extreme temperatures, high pressures, and the limitations of drilling technology at the time. The Soviets, however, were undeterred. They set out to create a borehole that would reach unprecedented depths, pushing the limits of human engineering and endurance. The drilling process was slow and arduous, taking over 2 decades to reach its final depth. By 1989, the Kola Superdeep Borehole had reached an astonishing depth of 40,000 feet, making it the deepest hole ever drilled by humans. To put this into perspective, the borehole extends more than 3 times deeper than the deepest part of the ocean, the Mariana Trench. It remains the deepest point on Earth's surface ever reached, a testament to human determination and the desire to explore the unknown. Drilling to such great depths was no easy feat. The deeper the borehole became, the more challenging the drilling process turned out to be. The temperatures at the bottom of the borehole reached a scorching 356 Fahrenheit, far higher than scientists had anticipated. The extreme heat, coupled with immense pressure, caused the rocks to behave unpredictably, often causing the drill bits to fail. In fact, the project faced numerous setbacks due to mechanical failures and breakdowns, necessitating the drilling of 5 separate boreholes to reach the final depth. These challenges highlight the difficulty of drilling into the Earth's crust. As the borehole deepened, the rock formations became more complex, with unexpected geological features that made the drilling process even more complicated. Despite these setbacks, the Kola Superdeep Borehole project pressed on, driven by the desire to uncover what lay beneath the Earth's surface. The Kola Superdeep Borehole yielded several surprising discoveries that challenged existing scientific theories. One of the most unexpected findings was the presence of microscopic plankton fossils at a depth of over 19,000 feet below the surface. These fossils, embedded in ancient rock formations, provided valuable insights into the history of life on Earth, suggesting that life existed much deeper within the Earth's crust than previously thought. Another significant discovery was the presence of water at depths where it was not expected to exist. Scientists found that water was seeping into the borehole from surrounding rock formations at depths far greater than previously believed possible. This finding challenged the assumption that water could only be found in the upper layers of the Earth's crust and opened up new possibilities for understanding the movement of fluids deep within the Earth. Furthermore, the Kola Superdeep Borehole revealed that the Earth's crust was far more complex than previously understood. Instead of finding basalt, a common volcanic rock, beneath the continental granite as expected, scientists discovered metamorphic rock, which is formed by the alteration of existing rock types through heat and pressure. This discovery provided crucial evidence supporting the then-nascent theory of plate tectonics, which suggests that the Earth's crust is made up of rigid plates that move and interact with one another. The findings from the borehole offered a glimpse into the dynamic processes shaping our planet's surface. The Kola Superdeep Borehole project was officially halted in 1994. partly due to the collapse of the Soviet Union and the resulting lack of funding, and partly because the project had reached its technical limits. Despite never reaching its initial goal of penetrating the Earth's mantle, the borehole remains a monumental achievement in geological science. Today, the site of the Kola superdeep borehole is abandoned, with the borehole itself sealed off and the surrounding facilities in disrepair. Yet the legacy of the project endures. The data collected from the borehole has provided invaluable insights into the structure and composition of the Earth's crust, and it continues to inform geological research to this day. The project also serves as a reminder of the challenges and rewards of scientific exploration, pushing the boundaries of human knowledge and our understanding of the natural world. While the Kola superdeep borehole remains the deepest hole ever drilled, it may not hold that title forever. Advances in drilling technology and a renewed interest in exploring the Earth's depths have led to new projects aimed at drilling even deeper. China, for example, has recently embarked on its own ambitious drilling project, aiming to reach depths that could rival or even surpass the Kola superdeep borehole. Earth's hidden heart. As we delve deeper into the Earth, the potential for groundbreaking discoveries grows exponentially. The Kola borehole, for all its achievements, has only reached about 12 kilometers beneath the surface, a staggering feat, but still just a fraction of the distance to the Earth's mantle. Imagine standing on the beach, digging a tiny hole in the sand, and claiming to have explored the ocean. That's the scale we're talking about here. But what if we could go further? What if we could drill deep enough to touch the mantle itself? This layer, which lies beneath the crust and above the core, holds the secrets to our planet's past, present, and future. The mantle is an enigmatic realm, a vast ocean of rock that makes up the majority of Earth's volume and mass. To put it into perspective, the crust, the thin outer shell where all life exists, constitutes a mere 1% of the Earth's total volume. The core, a dense sphere of iron and nickel at the planet's center, accounts for about 15%. But the mantle? It's the heavyweight champion, making up 68% of Earth's mass and 85% of its volume. And yet, despite its size, the mantle remains largely unexplored. It's not a churning sea of molten rock, as some might imagine. Instead, the mantle is solid, yet it flows, slowly, gradually, but surely, over geological timescales. To understand the mantle, picture a lava lamp. Near the boundary between the core and the mantle, rocks are heated by the core's intense temperatures. As they heat up, they become less dense and begin to rise. Like the blobs of wax in a lava lamp, these plumes of hot rock ascend toward the crust, but the journey is anything but swift. The process is slow and agonizing, so it takes millions of years for these rocks to complete their cycle from the depths of the mantle to the edge of the crust and back again. This slow movement drives the tectonic processes that shape our planet, from the drifting of continents to the eruption of volcanoes. But here's where the tension mounts. Despite our understanding of these processes, the mantle remains largely a mystery. We know it exists, and we have some idea of its composition, thanks to seismic waves that travel through the Earth and give us a glimpse of its inner structure. But we've never directly observed the mantle, never touched a piece of it with our own hands. What if we could? The implications are staggering. If scientists were able to drill down into the mantle to retrieve a sample of this ancient, untouched rock, it would be like finding a time capsule from the dawn of the Earth. Such a sample could reveal the raw materials from which our planet formed, offering insights into the early solar system and the processes that led to the creation of Earth. It could answer questions about how our planet evolved, how its layers formed, and how they interact with one another. It could even shed light on the forces that drive earthquakes and volcanic eruptions, potentially leading to better predictions and preparations for these natural disasters. But the road to the mantle is fraught with challenges. The deeper we drill, the more intense the conditions become. Temperatures soar, and pressures skyrocket, pushing our technology to its limits. And even if we could reach the mantle, the question remains, what would we find? Would it confirm our current theories? Or would it turn everything we know on its head? The mantle, for all its slow, steady movement, holds the potential to shake the foundations of Earth science. Deep dive into unseen layers. When we think about the Earth, we often imagine the surface we walk on, the oceans we swim in, or the sky above us. But beneath our feet lies a vast, mysterious world, much of which remains unexplored. One of the most enigmatic layers is the mantle, a colossal hidden realm that plays a crucial role in the dynamics of our planet. But how do scientists know so much about something they've never physically touched? The key lies in the study of seismic waves, those powerful tremors generated by earthquakes that ripple through the earth. These waves don't just shake the ground, they travel through different layers of the earth, each with its unique properties. By analyzing how these seismic waves move, their speed, and the paths they take, scientists can infer a great deal about the mantle's characteristics, such as its density, viscosity, and overall composition. It's like using an X-ray to see inside the Earth, revealing a world we can't directly access. But seismic waves aren't the only tools in a geophysicist's kit. The Earth's crust, the thin outer layer we live on, also offers clues. After a massive ice sheet melts, the crust slowly rebounds, a process known as isostatic rebound. By measuring how the crust springs back, scientists gain insights into the mantle's properties beneath it, particularly its ability to flow and deform. This information is crucial for understanding the forces at play deep within the Earth. Magnetic and gravitational fields also provide vital information. By mapping these fields, scientists can deduce the distribution of minerals and other substances within the mantle. Different materials interact with magnetic and gravitational fields in unique ways, allowing scientists to narrow down what lies beneath without ever needing to dig that deep. Interestingly, though, some mantle samples have made their way to the surface without human intervention. These samples have embarked on remarkable journeys driven by the Earth's dynamic processes. Some were hurled upwards during volcanic eruptions, others were pushed up through tectonic plate collisions, and a few managed to surface along mid-ocean ridges where new crust is being formed. These natural events offer a rare glimpse into the composition of the mantle, allowing scientists to study material that originated from tens to hundreds of kilometers below the Earth's surface. However, there's a catch. These mantle samples, while incredibly valuable, have been altered by their journey. As they rise through the Earth's layers and eventually reach the surface, they interact with air and seawater, which changes their original composition. This means that what scientists study isn't exactly the same as it was deep inside the Earth. To truly understand the mantle in its pristine state, scientists need an untouched sample, one that hasn't been exposed to the surface environment. The quest for such a sample is ongoing. Drilling deep enough to reach the mantle directly is no easy task. The deepest holes humans have ever drilled, such as the Kola superdeep borehole in Russia, only penetrated a fraction of the way through the Earth's crust, never reaching the mantle. The technical challenges are immense, with extreme temperatures and pressures making it incredibly difficult to go deeper. Yet, the potential rewards are compelling. An untouched mantle sample could provide definitive answers about the Earth's interior. It could reveal how the mantle conducts heat and seismic waves, offer clues about the formation of the Earth, and even challenge or confirm existing theories about our planet's structure. The insights gained from such a discovery could revolutionize our understanding of geophysics and Earth's history. So, why haven't we succeeded in reaching the mantle yet? Simply put, the technology and methods required to drill that deep are still in development. Previous attempts have been met with limited success, often halted by the immense challenges posed by the Earth's extreme conditions. The global history of deep drilling. The quest to drill deeper than ever before became a symbol of technological prowess and national pride. This subterranean competition, driven by both scientific curiosity and the desire for geopolitical advantage, saw some of the most brilliant minds of the time push the boundaries of what was possible. The United States was the first to step into the deep drilling arena. In the late 1950s, a group of American scientists, engineers, and visionaries came together under the banner of the American Miscellaneous Society. Their mission was as ambitious as it was unprecedented: to drill down to the Earth's mantle, the layer that lies beneath the planet's crust. This endeavor was named Project Mohole, after the Mohorovičić discontinuity, commonly known as the Moho, the boundary between the Earth's crust and mantle. What made Project Mohole particularly intriguing was not just its ambitious goal, but the innovative approach it proposed. Instead of drilling through the Earth's thick continental crust, the Society's team decided to take a shortcut by drilling through the ocean floor. They identified a location near Guadalupe Island in the Pacific Ocean, where the Earth's crust is significantly thinner. This strategy, while promising, introduced its own set of challenges. Before they could even begin drilling into the crust, the team had to overcome the daunting task of reaching the ocean floor, a feat that required navigating the depths of the Pacific. As the Americans pursued their deep drilling dreams, the Soviet Union, ever eager to match and surpass its rival, embarked on its own journey into the Earth's depths. In 1970, the Soviets began drilling on the Kola Peninsula, a remote and icy region in northwestern Russia. This project, known as the Kola Super Deep Borehole, would go on to become one of the most famous deep drilling endeavors in history. Meanwhile, in Germany, a third major player entered the race. The German Continental Deep Drilling Program, initiated in 1990, aimed to explore the Earth's crust beneath Bavaria, reaching impressive depths of nearly 30,000 feet. All three of these missions, despite their differences in location and approach, shared a common challenge: the need for new technologies. The further they drilled, the more they encountered conditions that had never been faced before. High temperatures, immense pressures, and the sheer unpredictability of the Earth's interior meant that these pioneering teams were often working without a roadmap. It was as if they were building a spacecraft for a mission to the moon, only to realize that they also needed to invent the rocket along the way. For the engineers and scientists behind Project Moholy, one of the most pressing challenges was keeping their drill ship steady while drilling into the ocean floor. At the time, the technology known as dynamic positioning, which allows a vessel to maintain its position over a drilling site, had not yet been developed. In a display of ingenuity, the team devised a solution that involved adding propellers to their drill ship, enabling it to stay stable over the borehole. This innovation was just one of many that would later be adopted by the oil and gas industry, illustrating the broader impact of these ambitious scientific projects. The German team, too, faced its share of challenges. One of the most critical was ensuring that their boreholes remained as vertical as possible, a task that required precise engineering and constant adjustments. The solution they developed has since become a standard practice in deep drilling operations worldwide, highlighting the lasting contributions of these early drilling efforts. Despite the remarkable technological advancements and the dedication of those involved, these deep drilling projects were far from smooth sailing. Each mission faced numerous setbacks, from unexpected blockages to equipment failures. High temperatures deep underground proved to be a formidable adversary, often pushing drilling machinery to its limits. The costs associated with these challenges were astronomical, leading to budget overruns that, in some cases, became too much to bear. One of the most notable casualties of these financial pressures was Project Moholy. Despite making significant progress, the project was abruptly canceled in 1966, just 2 years before Neil Armstrong's historic moon landing. The decision to pull the plug was driven by ballooning costs and a lack of political will to continue funding such an expensive endeavor. The dream of reaching the Earth's mantle was left unrealized, a reminder of the harsh realities that often accompany scientific exploration. The Kola Super Deep Borehole, which still holds the record for the deepest man-made hole on Earth, also faced its own set of insurmountable challenges. In 1992, after more than 2 decades of drilling, the project came to a halt. The drilling equipment, not designed to withstand such conditions, began to fail, and the costs of developing new technologies to continue the project were prohibitive. With the collapse of the Soviet Union in 1991, funding dried up, and the project was abandoned, leaving the borehole as a testament to the limits of human ambition. Today, the Kola Super Deep Borehole has become a destination for adventurous tourists, drawn by the allure of standing at the edge of the deepest hole ever drilled. The site, once a hub of scientific activity, is now a relic of a bygone era, a reminder of the Cold War's relentless pursuit of technological superiority. In contrast, the German borehole has had a different fate. While it too faced its share of challenges, the site has been preserved and transformed into a tourist attraction. The massive drill rig, once used to penetrate the Earth's crust, has been repurposed into a crane for lowering instruments into the borehole, allowing visitors to explore the depths of the Earth in a new way. As for the United States, while Project Mohole may have ended in disappointment, the country's deep drilling efforts did not stop there. In 1968, the U.S. launched the Deep Sea Drilling Project, an international program that operated until 1983. This project was a resounding success, significantly advancing our understanding of the Earth's geology. Among its many achievements was providing critical evidence for the theories of continental drift and seafloor spreading, which played a crucial role in confirming the theory of plate tectonics. China's ambition. After years of preparation, China has begun work on 2 super-deep drilling projects that aim to delve into the Earth's crust at unprecedented depths. This move sends a clear message to the Western world. China is not just ready to compete, but to lead in scientific exploration. Backed by substantial financial resources and driven by a relatively short timeline of just 15 months, China's efforts are a bold statement of intent. These projects are not just about breaking records, but about making significant advancements in our understanding of the Earth's composition. The stakes are high, and the potential rewards are even higher, as China gears up to possibly break new ground, literally and figuratively. The future of deep drilling. The question on everyone's mind is whether these drills could eventually lead to an attempt to reach the Earth's mantle, a feat that has long been the holy grail of geological exploration. While this might still be a distant goal, the success of these current projects could very well pave the way for even more ambitious undertakings in the future. Beyond the political motivations that might be driving this race, there is a deeper, more profound purpose at play: the quest for knowledge. Each layer of the Earth that these drills penetrate brings us closer to uncovering the secrets buried deep within our planet. The history of boreholes shows that this is more than just a technical challenge. It's a testament to humanity's insatiable curiosity. Beneath our feet lies a game-changing energy source, one that could revolutionize how we power the world. Supercritical geothermal energy, a potent and untapped clean energy, is buried up to 20 kilometers beneath the Earth's surface. Imagine a vast natural battery as powerful as fossil fuels, but as clean as solar, wind, or hydro, and with a much smaller land footprint. This innovation holds the promise of preserving forests, protecting wildlife, and transforming our energy landscape. If we could harness this geothermal powerhouse on a global scale, it could eradicate energy poverty, slash greenhouse gas emissions, and create millions of jobs. The only obstacle? Overcoming the daunting engineering challenge of drilling to such depths. Thanks for watching. Stay tuned for more.